Hello guys, welcome to another video. In this video, we will be studying about all the laws and properties of exponents. So there are 3 laws and 3 properties. So we will be going through each of the property one by one with explanation. So let's start. First law we have product law. A raised to m multiplied by a raised to n is equal to a raised to m plus n. Okay, so let's see if this works or not. Let's say a is 2, m is 3, n is 4. Okay, so we have assumed these numbers. Let's try the LHS and let's see if we get the RHS. So let's plug in the values. So we'll get 2 raised to m is 2 raised to 3 multiplied by 2 raised to 4. So this will become 2 raised to 3. So 2 is getting multiplied by itself 3 times. So we can just write 2 multiplied by 2 multiplied by 2. And 2 raised to 4 means 2 multiplied by 2 multiplied by 2 multiplied by 2. So this is the 3 times, this is the 4 times. Right? Now, so we have 3 times and 4 times. But in total 3 plus 4 we have 7 2's. So can't we write this directly? 4 plus 3 is 7. So can't we write directly 2 raised to 7? Hence this will become a raised to m plus n, because m plus n is 7. Okay, let's go to the next one. So we have the second law over here, quotient law. What does it say? If m is more than n, then a raised to m upon a raised to n will be a raised to m minus n. And if m is less than n, then a raised to m upon a raised to n is 1 upon n is 1 upon a raised to n minus m. Okay, let's go one by one. First case, a is 2, m is 4, n is 3. So m is greater than n. So let's try the LHS. So a raised to m upon a raised to n will become 2 raised to 4 upon 2 raised to 3, right? Now, let's expand this. So 2 raised to 4 we can write 2 multiplied by 2 4 times, correct? Upon 2 multiplied by 2 multiplied by 2 3 times over here at the bottom. Now, can you see one thing? There are 3 2's getting multiplied here and there are 4 2's multiplied up. So can we cancel these 3 2's with the 3 2's above? Yes, we can. So basically you can cancel this like this and we will get answer 2. And this 2 basically is 2 raised to 4 minus 3, which is 2 raised to 1, which is 2. Right? So basically, why do we write minus sign? Because the excess power, wherever it is, so in the numerator it is excess power, in the denominator there is only raised to 3, so it will get cancelled out, and the what is left over, which is 4 minus 3, will be left in the numerator. So let's try here. Now it is the same way, we'll just see how it happens. So a raised to m upon a raised to n. Also one more thing, this a and a should be same, only then we can cancel it. So please keep that in mind. This a number, the base should be the same. A raised to n will be, so we can write 2 raised to 3 upon 2 raised to 4. Now let's expand. 2 multiplied by itself 3 times upon 2 multiplied by itself 4 times. Right, now what do we get? Again, we can cancel, but the excess power is in the denominator, so 1 2 will remain here. So 3 2's here cancelled. We will get 1 upon 2. Right, now isn't this the same thing as 1 upon 2 raised to n minus m, which is 4 minus 3, which is 1 upon 2 raised to 1, which is 1 upon 2. Okay, the third law, power law. What does it say? What does the power law say? A raised to m, the whole raised to n is equal to a raised to mn. So m and n are multiplied together. Okay, let's see how it works. A is 2, m is 3, n is 4. Let's assume that. And we want to find out whether a raised to m the whole raised to n is equal to this. Let's plug in the value. So we have got 2 raised to 3 the whole raised to 4. Now we'll expand this inside the bracket only. We'll expand 2 multiplied by itself 3 times the whole raised to 4. Okay, I've only changed the inside part. Now look at one thing. This whole inside part, it is raised to 4. So this inside part is getting multiplied by itself 4 times. That means how many 2's will be there? Right, there will be 12 2's because here there are 3 2's, and if this whole thing gets multiplied by itself 4 times, then there will be 12 2's. Let's check. 2 multiplied by 2 multiplied by 2. So this whole thing we have to multiply 4 times. So this is 1 time, then 2 time, then 3 time, then 4 time. Now when you open the bracket, doesn't affect anything. So there will be 12 2's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 2 raised to 12, which is a raised to mn. So m is 3, n is 4. So 3 into 4 is 12. So 2 raised to 12. That's the answer. Basically, if we have a raised to m and its whole raised to another power, then the powers will get multiplied. Okay, let's move on to the next. Okay, let's look at the distribution property over here. First one, ab the whole raised to m is equal to a raised to m, b raised to m. So the power, when the brackets are opened, it gets distributed only when they are in product or in division. Same with division, a raised to b the whole raised to m, the powers are distributed. So a also gets and b also gets when you open the bracket. Remember, this does not happen when it is in addition or subtraction. Okay, now let's check. So we are assuming a is 2, b is 3, m is 4. Let's understand now. So a, b the whole raised to m will be 2 multiplied by 3 ab the whole raised to 4. Right? Now, this whole part, the whole bracket is getting multiplied by itself 4 times. So, one, 2, 3, 4. Okay, now let's open the brackets. Now, look at the 2's here. We can write them together. So, multiplication is commutative. So, we can rearrange them. So, we can write all 2's together first. 2 into 2 into 2 into 2. And all the 3's afterwards. 3 into 3 into 3 into 3. Okay. How many 2's are there? 4. How many 3's are there? 4. So, can we write this as the reverse process? Can we write this as 2 raised to 4 multiplied by 3 raised to 4? Isn't this the same thing as here? So 2 into 3 the whole raised to 4, we wrote it as 2 raised to 4 into 3 raised to 4. So when the brackets are opened, we can distribute the power to each number in product. Let's try it with the division. So a by b the whole raised to m would become, so we have 2 upon 3 the whole raised to 4, right? So now this whole fraction will get multiplied by itself 4 times. So 2 by 3 into 2 by 3 into 2 by 3 into 2 by 3, right? Now we can simply write it like this: 2 into 2 into 2 into 2, 3 into 3 into 3 into 3. Now same thing, this we can write as 2 raised to 4 upon 3 raised to 4. Okay, second one, a raised to 0 is 1. How do we prove this? Let's see. Okay, answer me this. A raised to 3 is how much? A getting multiplied by itself 3 times. A into A into A. Right? Now A raised to 2 is A into A. A raised to 1 is only A. Now A raised to 0 is question mark. Now notice one thing. If we want to find A raised to 1, we can just divide A raised to 3 upon A raised to 2. So this will become 3 times A. This will become 2 times A. Cancel, cancel, we get A raised to 1. So 3 minus 2 is 1. Basically, the exponents are getting subtracted. So this is basically A raised to 3 minus 2. Now let's try A raised to 0 will become, we can write it as same power in the numerator and denominator. So we can write A raised to, let's say, any number, 5 upon A raised to 5. This will become A raised to 5 minus 5, which is A raised to 0. Right? And also in another way, we can just cancel this and it will become 1. So that's why A raised to 0 is 1. Okay, the last property, negative index. Let's see this. So look at this example. So look at this law when m is less than n. So let's apply this. So we have taken A is 2, m is 3, n is 5. Let's apply A raised to m upon A raised to n will become 2 raised to 3 upon 2 raised to 5. Okay, now there are two ways to do this. Let's use by formula and then let's use by expanding. So what does the formula say? Formula says that you subtract the m and n. So basically you just subtract it. So 2 raised to 3 minus 5, which is 2 raised to minus 2. Okay. So whenever it is in division, we subtract the powers if the base is same, and in multiplication we add the powers if the base is same. Okay, so with formula we got 2 raised to minus 2. Now with expansion, let's see what do we get. So we can write 2 into 2 into 2 upon 2 into 2 into 2 into 2. 5 times, so 5 times 3 cut, 3 cut. So we got 1 upon 2 raised to 2. So basically negative index we can write as this. So 2 raised to minus 2 we can write 1 upon 2 raised to 2. So whenever you have a negative power, you can just reciprocal it. If there is 3 raised to minus 5, we can write this as 1 upon 3 raised to 5. If there is 5 raised to minus 10, we can write this as 1 upon 5 raised to 10. Let's say we have 1 upon 2 raised to minus 6. So we can bring it up now. So it gets reciprocal. So we can write 2 raised to 6. I hope you have understood this video. Thank you for watching.